Welcome to the Calculus AB video for skill number 101. I can use and apply the standard, point-slope, and slope-intercept form equations with lines and pairs of lines. And the trivia question for this video is, the picture below is of what famous Greek temple, and even more importantly, what is this portion of the Greek temple called? Alright, we'll begin our notes on page 101A. And for this skill, there are three line equations that we are interested in. The first is the standard form, which is ax plus by equals c. And in this form, a should be a positive number, and a, b, and c should be integers. So that notation right there, c is an element of the integers. When we have the standard form equation, we can find that the slope is equal to negative a over b. We have a 0 or an x-intercept at c divided by a. And we have a y-intercept at c divided by b. This piece is less important, though I will make use of it. These things are key to us. The point-slope form is the second line equation, and it comes in the form of y minus y1 equals m times the quantity of x minus x1. This equation is great because it tells us the slope and it tells us that it passes through a point at x1, y1. Hence the fact that it's called point-slope form. It is very commonly used in calculus. And the third line equation is the slope-intercept form, y equals mx plus b. This is perhaps the first line equation that you learned back in Algebra 1. It has a slope of m and a y-intercept of b, hence the reason it's called slope-intercept form. So a student should be able to convert between these three forms and generate these three forms given relevant information. So here I've written three common conversions. A lot of times we'll go from point-slope to slope-intercept, or even point-slope to standard. And then finally, another common one is moving from slope-intercept to standard. So we also move in the opposite direction, standard to slope-intercept. This isn't terribly important to know that these are common, but we should be comfortable doing any possible conversion between the three. Alright, since we're at the calculus level, I'm just going to jump right into a harder type of problem than the straightforward ones. This says, find the equation of a line parallel to y equals 2x plus 3 that passes through 5, 7. Write your answer in standard form. When I see the expression passes through, that clues me in that I should be using the point-slope form, which I've written down here. And the first thing I do is I substitute the point it gives us in 5, 7 for my x1 and y1. x1 is 5, y1 is 7. And then I need to find my m. And if the line is parallel to y equals 2x plus 3, where m is 2, then m of our parallel line will also be 2. So we can plug that in here. And we now have our equation in point-slope form. And this would be a decent spot to stop, except the problem asks us to write it in standard form. So I'm going to convert the equation to standard form. Here's our equation, and the first thing I do is I distribute the 2 in, then I move the 7 to the right-hand side, and at this point we're in slope-intercept form. And then I move the 2x to the left-hand side of the equation, and this looks like standard form. The only reason it's not is because our leading coefficient, a, is negative. So I multiply everything by -1 and I get the standard form of the equation. So in this we passed from point slope to slope intercept to standard. So we practiced that conversion process. Let's take a look at a second example. Example 2. Find the standard form equation of the line through 3, -1 that is perpendicular to a line that passes through 2, 4, and 3, 1. So we have a line that passes through 2, 4, something like that, and 3, 1. So we have this red line, and we want a line that is perpendicular to it. So something like this or this or this that passes through 3, -1. So probably about this line, 3, -1. So the first thing we need to do is we need to find the slope of our red line, because that will enable us to find the perpendicular slope. So we find the slope of our red line by using our slope equation, y2 minus y1 over x2 minus x1. And we find that there is a slope of -3. So if I wanted to annotate this drawing, it has a slope of -3. Which means our perpendicular slope, or the slope of our blue line, is 1/3. So something like that. And at this point you can tell my drawing is not to scale very well. Anyway, line 2, we have a slope now, and we have a point that it passes through. So we can use the point slope equation. We plug in y1, we plug in our slope, and then we plug in x1. And right here we have a decent equation. The only thing is it tells us to write it in standard form. So what we're going to do is convert it to standard form. In the first step, I got rid of the parentheses here. In the second step, I distributed the 1/3. In the third step, I subtracted 1 from both sides, and now we're at the slope-intercept form. And then in the fourth step, I moved my x term to the left-hand side, and then I wanted to make it standard form, so I made all numbers integers, and then I made my leading coefficient a +1. So this is the standard form. In all, we should be able to create equations for lines given either points or slopes or 2 points, and we should be able to convert between our forms. So that's the skill. Alright, this concludes the video for Skill 101. I can use and apply the standard, point slope, and slope-intercept form equations with lines and pairs of lines. And the answer to the questions is, this is the Temple Parthenon, and it is located in Athens, Greece. And this top step here is called the stylobate.